Okay, we are going to go over some of the practice problems in the book. I know a few students expressed some confusion about these, so hopefully I can clarify a few things up. In practice problem A, this is number 48 on page 92. You are to use dimensional analysis and the given densities to make the following conversions. You're going to convert 14.8 grams of boron into centimeters cubed of boron, and the density of boron is 2.34 grams per centimeter cubed. So we'll write down what we start with, which is 14.8 grams of boron. Now we want to convert to centimeters cubed. We can use this density of boron as a conversion factor. Notice that the units are in grams per centimeter cubed. If I rewrite this as a fraction, and I put centimeters on the top, in other words, so in 1 centimeter cubed, I have 2.34 grams of boron. That's essentially what the density is saying. And when I do that, and I look at my units, grams now here is in the denominator, grams here is in the numerator, they cancel out, and I'm left with centimeters cubed. In a conversion factor, the units that are in the numerator of the conversion factor are the units that you're going to end up with in your answer, and the units that are in the denominator of the conversion factor are the units that are going to get canceled out. So when I do my math, I end up with 6.32 centimeters cubed. Remember that I need to express my answer to the correct number of significant figures. I have 3 significant figures here. In the conversion factor, remember that conversion factors are considered to have an unlimited number of sig figs, and they do not count in the rounding process. So our answer is 6.32 centimeters cubed. We have a similar problem down here. I'm starting out with 4.62 grams of mercury, and I want to find out how many centimeters cubed of mercury I have. Here's my density of mercury. I can turn this into a conversion factor. So for every 1 centimeter cubed of mercury, it will hold 13.5 grams. So now by doing that, I've put centimeters cubed up here in the numerator. That's the unit I want to end up with. Grams is in the denominator, and that will cancel out with grams over here. Okay, so grams and grams cancel out. I'm left with centimeters cubed, which is what I want in my answer. So when I do my calculations, this is the same as 4.62 divided by 13.5, and my answer is 0.342 centimeters cubed. Remember that I have to express my answer to the correct number of sig figs. I have 1, 2, 3 sig figs here. The conversion factor doesn't count, so my answer has 3 sig figs. So these are density problems, essentially, but you're given the density and you're given the mass, but now you need to find the volume. So you can do that by using this conversion factor. The other way that you could have done it was thinking about density equals mass divided by volume. So we have an algebraic expression here. We can solve for volume by multiplying each side by volume. So volume and volume would cancel out, and what we're ending up with here is volume times density equals mass. Solving for volume, we divide both sides by density. That makes density cancel out here, and we end up with volume equals mass over density. Okay. And essentially that's what we've done over here. We've taken the mass and we've multiplied by the inverse of the density. This is the density flipped around. which is the same as dividing by the density. We've done the same mathematical operation here in this problem as we've done over here when we solved for the variable. We would have come up with the same answer.